my name is Dana Golden. I'm going to walk you through the CREST tool. This is put out by the National Renewable Energy Lab. You just search for NREL CREST, and you have a bunch of, let me increase that to 100 so that you can see it. So you have a bunch of different variables you can put in. You have the units here, and then you have the input value. So you have a general nameplate capacity, you have a net capacity factor. These are good starting values for your project. Obviously, you want to adjust it based on what type of project you're looking at. You can adjust the OMM cost. You can adjust what insurance you're going to have to use. You just land leases based on how much you think they're going to cost. You can, based on the interest rate, adjust the debt term, how long the loan has to be repaid by. And you can adjust the interest rate on term debt. And you can also adjust the length of the project. In this case, the useful price of the project is usually 20 years. Let's adjust this up to 7. I think that was the one this came with. And you get some results. Here, we run it once. 7%. And you get some summary results, which give you a baseline level for the net 1-year cost of energy and then the net nominalized levelized cost of energy given a set of inputs. You can look at the cash flows over time. You can look at how the cash flows change over time. So you have to invest in the project. You have a very high negative outflow in the project, and then very quickly it has a positive cumulative cash flow over time. You have the revenues here. You have the operating expenses here, debt service. And so this is a really great tool for thinking about how much things cost and how this is impacted by different possible inputs. You can change the interest rate and see what is the effect if we change inflation or we change interest rates. You can change the capacity factor. You can see what if actually we have a way higher capacity. And if you'll notice, cumulative cash flows are going to go up. And then the net nominalized cost of energy is going to go down. We can also change the interest rate. So let's say the interest rate was 3% on long-term debt, and now we made it 6%. What's going to happen? What do you think is going to happen to LCOE? It was about 9 before. What's it going to be now? 9.75. So interest rates go up as the levelized cost of energy goes up. This is offshore wind. It has a useful life of about 20 years. I would love for you, when you're doing this on the homework, take this very seriously. Look through these spreadsheets, understand what's going on, how these numbers are calculated. Look through these formulas. Look at the relationships between these numbers and where they're coming from. So how does higher operations and maintenance in this input affect these things? So this is something you could very well be asked to do. And then you can also, here's where you change the depreciation schedule. Non-depreciable. Who wanted that? I don't know. Someone is happy with a non-depreciable asset. But yes, you can change all the variables. I recently worked on a paper that we think is going to go towards IEEE Access, which is the multidisciplinary IEEE journal. And we did a lot in this interconnection to showcase how LCOE changed between HVDC and HVAC. So the nice thing here is you can look directly at how economic variables impact feasibility and how technical variables impact the economics. And I hope this was helpful. I'm happy to answer any question during office hours. And I hope you have fun with this tool. Maybe even look at the one for solar. Look at the geothermal. Look at how it's different. And if you want to, I would love for someone to do a full course project where they work with this tool and do some analysis.